Happy to be here. Thanks to Samuel for the invitation. We will now try to investigate a little bit about the environmental impact of the energy transition, let's say, on the energy future facing environmental challenges. I'm very happy to have today here very interesting panelists. First of all, Loriane Kohler from Cycle. You will present yourself later on. Then Frederic of D-Carbonize and Reinhold Ungern-Sternberg from the German SME Association, der Mittelstand-Berlin. My name is Stefan Moritz. I'm the Secretary General of European Entrepreneurs, CEA-PME, which is a European Confederation of SME associations, and we are, of course, deeply concerned and engaged also in the field of green transition, which is both our necessity but also our difficulty to make it work together with the European and with our millions of companies in Europe that are trying to stay at the pace that is required as much as possible in the transition towards sustainable growth. However, also many other challenges, environmental in particular, must be addressed to ensure that transition to renewable energy production is really sustainable and beneficial, not only for the environment, but also for companies, in particular small and medium enterprises, which are the backbone of our economy in Europe, I would say also in Canada for sure, and also for citizens and countries. To minimize the negative impact of renewable energy production or also of the energy transition in general, it is crucial to carefully consider the location and the design of it. So let's say we of course start to produce the energy very far away, we must also think about how to bring it here. I mean, otherwise Iceland would have already solved our problem. They have energy without end. But we of course have to build then, let's say, infrastructures, and these infrastructures have costs, environmental costs, also only think about the concrete or steel that we need for the wind energy, and of course also other renewable energies which might, or solutions like carbon sinks, which might somehow have impacts. So proper planning, community engagement, but also engagement of the small business enterprises, which are most innovative in the field of energy production, because they test and go ahead, and maybe solutions will be taken over later on. And they have to be involved in order to help identify and address potential environmental, economic and social issues, but to ensure that renewable energy production will be sustainable and beneficial, but also competitive for all stakeholders. Additionally, of course, innovation in environmental energy technologies and manufacturing processes can help to reduce environmental footprint of energy production, renewable energy production, make it more sustainable and environmental friendly. I would like to ask immediately to my colleague Reinhold from Ungern-Sternberg from Germany. He's director of the international markets of BMW. The environmental transition in EU and Canada has set an ambitious target on reduction of CO2 emissions by 2050. Many might say, it's 27 years, a long time, no? But it is maybe, anyway, not easy. Other countries have chosen different ways. For example, China has said we will do it only in 2060. India immediately said, no, we will do it in 2070. So they have already 10, 20 years of competitive advantage in their plans. And of course, setting also this high target, we have markets reacting, and they say, ah, you have this high target, wonderful. What do you need, lithium? Oh, great, that costs 20% more. So it's not easy to announce here in programs and plans our transition. What, from your point of view, from the German SMEs, what is your take on that, and how would you, let's say, define a good progress towards this objective?
Yes. Thanks, Stefan. Can you hear me?
Say also some words about yourself, maybe, please.
Maybe it works now. Thanks, Stefan, for the question and the introduction. Of course, as the largest voluntarily organized business association in Germany and in Europe, we have lots of members who care mostly about energy prices now. But starting from the political initiative to reduce carbon footprint, of course, everybody thought we are on a good track until the beginning of last year, and then the situation dramatically changed, as you know. So on the level of the EU member states, as well as on the EU level, there was a good plan towards decarbonizing industry and economy. And still we have these ambitious targets, and they even became more ambitious. And we have lots of companies who are engaged and involved in such technological progress, but that is really needed for that. But last year, with the Russian invasion in Ukraine, the situation dramatically changed. And not only Germany, but mainly Germany and other member countries are focusing the issue of getting gas for heat consumption mainly, but also for energy. And we need to import other energy resources from other parts of the world, and we even go to visit not just Qatar and Australia, but also Canada, about such a topic. So we still have these ambitious targets to reduce CO2, and now on the European level there was the discussion about Green Deal, about taxonomy, and the solutions were which energy resources are CO2 neutral. And again, most of the European countries, not the Germans, prefer now nuclear power plants as well. But Germany, on top of all this crisis, choose to go out of the nuclear energy as well. So now we are relying heavily on the European strong grids, and companies and member countries of Europe are buying and sharing energy now all the time, but we even increased coal production for energy. So we are a bit in a dilemma, and but still we are very much investing heavily, the companies and the member countries with EU fundings as well, into renewables.
So I see it's quite a challenge if the rules are quite tight. Of course, let's say the large quantities of energy means also large quantities of raw materials. Just think about the batteries, and think about that the batteries we don't have currently that mining capacity in Europe for cobalt and lithium that we might need, and there are other continents and other countries that can help here, but at the end this all goes to China first, and to produce then the batteries, and then it comes to Europe, so all the CO2 on the cycle is also included. Let's say when we have an electric car, Loriane, we're talking about raw materials in the near future. How can we manage this challenge here in Europe and Canada, where we largely depend on these imports?
Thanks.
Good. Yeah. Otherwise, take Reinhold's.
Yeah. So thanks a lot for the question. Maybe I'll go back and share a few words on what we're doing at Lifecycle, so you understand our perspective on this lack of supply on critical raw material. So Lifecycle was founded in 2016 in Canada to address an alternative problem to the use of clean energy, is that we didn't have a sustainable solution for recycling end-of-life lithium-ion batteries. So our co-founders developed a patented, safe, sustainable, and scalable spoke and hub technology, as we say, to really have the possibility to recycle at very high recovery rates those critical materials that you mentioned, so cobalt, lithium, and nickel, which we can recover up to 95% and put back into the battery value chain. We are currently developing our model in North America, where we have 4 spoke facilities. So the spoke facility are where we shred the batteries through a mechanical process to separate out the black mass, and then we centralize this black mass in what we call the hub, where we have the possibility through a hydrometallurgical process to recover those constituent materials, including cobalt, lithium, and nickel. So we have planned for a hub that will start commissioning in Rochester in the state of New York in the US by later this year. And we also have plans here in Europe to develop a local closed loop system with a significant planned hub that will hopefully come off the ground in Sardinia, Italy by 26-27. And it will be one of the largest sources of recycled lithium on the continent. So to your question on how will we find all these materials that are needed for the clean energy transition, because of course it's a very significant amount, but I just want to take maybe a step back and also compare to our current system based on fossil fuel. So it's estimated that by 2040 we'll need 30 million tons of critical material for developing clean technologies. But if we compare it to the amount of coal that is needed every year, also by 2040 it's estimated that we'll still have a demand of 5,000 million tons of coal every year. So you see the order of magnitude is very different. In reality, we'll still be reliant on mining for a critical mineral for decades to come. By 2040 also it's estimated that 2/3 of materials would come from mining, but it still gives us the other side to have 1/3 of material coming from local recycling. And that's what we're trying to do at Lifecycle, is to take an advantage of this possibility to recycle an infinite number of times cobalt, lithium, nickel that are contained in the batteries, which is not possible for any type of product. So it's a chance that we have this possibility to close the loop for batteries specifically. And that's what we're doing regionally, as I said, in North America, but also in Europe. We actually opened our first spoke facility in Germany a couple of weeks ago, where we already have the capacity to process 10,000 tons of battery material per year. So this includes the small portable batteries that you have in your phone, in your laptop, but also the bigger electric vehicle batteries, and also manufacturing scrap from the production side. Because actually we see that the industry is also developing here in Europe with battery production capacity increasing over time, and we have to respond and align to this growth in the market.
That's very encouraging, thinking about that, what you say, because that means also we have less critical waste that we might currently, unfortunately, is also exported to other continents. Everybody knows what I'm speaking about, and that would be absolutely beneficial for both continents and for the world to continue better on your street. Frederic, John, you are from D-Carbonize. Let's talk a little bit about our current situation with the CO2 emissions. One could say our planet is burning, and even Canada and the EU would have to do something. If they would stop now, today, producing CO2, would that still stop this reality from changing, or our strategies to be adapted to fight against climate change and global warming in another way?
Yeah, thank you very much, Stefan, for the question. And indeed, our planet is burning. When you look at the forest fires in Canada, it represents roughly the half of the GHG emissions that we emit in a year in the entire European Union. So it's a lot of CO2. So now back to your question about the strategies. Well, let's have a look at a global scale. what we are doing in Canada and in Europe in terms of regulation, it's really remarkable. We are at the forefront of climate regulations. So now we'll be talking about Europe because we are sitting just right to the European Commission, so we know what's going on over there. You've got some coming regulations such as CSRD, the Corporate Sustainability Reporting Directive, the carbon tax, CBAM, CSDD, and so on. You know, all these acronyms that are a bit of a nightmare for ESG managers now based in Europe. And they are considered by other countries, regions, governments, states, some of them as the way to go, the way to follow, the regulations we should align with. And I was very surprised when I did a bit of a review at a global scale what's going on in other regulations. Some of them are trying to catching up. I can give some examples. If you look at the bill that was passed two weeks ago in California, in Mexico as well, you've got some very tight regulations. In Taiwan, which is very important for us with the microchip and so on. So other regions are following our path, and it's very encouraging because it will avoid some commercial distortions and some inequalities maybe we can face at the global business. So now what's going on the ground? How are companies reacting to that? I found a very interesting survey from BCG not long ago. And they said that 80% of companies have targets to reduce their CO2 emissions. That's great. But in reality, only 9% of them successfully reduce their CO2 emissions. So what happened? And there is one simple reason. It's because we cannot reduce what we do not measure. And this is a very important message to remember. It's a bit like, well, a few years ago, I did a diet. What was the first thing that I did? I bought a scale. I bought a scale because I wanted to have a diagnostic of what was my weight and monitor my progressions so that I could be encouraged and keep going towards the right direction. It's exactly the same for companies, for businesses, and even for us at an individual level. We need to measure what we emit in order to reduce our CO2 emissions. So the reality is companies are now more in a learning mode, awareness mode, to learn a bit what's the carbon footprint, what's a carbon strategy, whereas the climate emergency would require us to be in a acting mode, in a reducing mode. But that's not yet where we are right now. And the consequence is that companies are a bit blind. It's a bit difficult to know where to reduce if we do not measure it. And so they invest a lot of resources, money, time, and so on into projects that are maybe not that meaningful in terms of environmental footprint. And these resources could have been invested in other fields, other branches of the companies where the impact would have been a bit bigger. And also because there is a lack of awareness and understanding of what are the emissions. We are now a lot claiming and playing with words such as carbon neutrality or net zero and so on. And this is great. I mean, this is what our regulations are encouraging to go for. This is what the IPCC encouraged us to go for. But there is a downside of wanting to be carbon neutral or climate zero too soon. And the downside is some companies are discouraged because it's too difficult or they don't know how to do it, so they don't do anything until there will be penalties. And you have the other side of it that they are too optimistic and companies want to beat the game and be carbon neutral, for example, next year or by 2025 or very, very short-termly. But this requires a reduction target that are almost impossible to achieve. And so the downside of it is we take a shortcut and we invest in a carbon offset project and so on. So I'm not saying it's not the right way, but with the resources that are invested in a carbon offset project, we could have used those resources to effectively reduce CO2 emissions and to invest into new technologies to reduce these emissions. Yeah. So really my takeaway here is to measure CO2 emissions in order to know where they're emitted so that we can reduce them.
That means very much also what our confederation claimed in its last manifesto for a realistic industry policy that we have to measure better what we are doing. Loriane, please, the CO2 emissions, are they the only aspect that we have to take into account in tackling environmental challenges, or are there others in the field of the climate change, of course?
Yeah, thank you for the question. Yeah, of course, it's very interesting, as you mentioned, to track the emissions, to see exactly where are the impact. So first, I wanted to maybe highlight that actually the use of recycled material in the production of clean energy has a really significant impact on the total greenhouse gas emission through the process. So we estimate that greenhouse gas emission associated with electric vehicle could decrease by 14 to 23% by 2040, if, as I said before, as I said before, we use 1/3 of recycled material in the production. Mm-hmm. Then I want to say, from a recycler perspective, we take into account two aspects when considering the sustainability of battery recycling. First is to reduce the need on virgin raw material, and second is the sustainability of the process in itself. So first, on reducing the need for virgin materials, we see that we can take advantage of this possibility to recycle in an infinite number of times at very high rates. So as I mentioned before, at Lifecycle, we recover those critical raw material up to 95%, which is very significant and gives the possibility to close the loop also locally, as I said. So we're doing that in North America, but also in Europe. And that's that will have a significant impact on reducing our dependency. And we also have at Lifecycle the possibility to take in all different type of feedstock. So I mentioned before the small portable batteries, electric vehicle batteries, manufacturing waste, but we also don't make a difference between chemistry, size, state of health, state of charge, which gives the possibility to recycle a very large feedstock and not to discharge any kind of waste that holds valuable materials within it. And so the second aspect, and I'll go into the direction that was mentioned before, is on how do we measure whether we are doing something sustainable in our battery recycling process. So at Lifecycle, we did our own LC analysis and compared it to minerals coming from traditional mining and refining. And we can see that compared to that, CO2 emission can decrease up to 67% if we use our technology compared to mining and refining, and also a reduction of up to 90% for SOx and NOx emission, which also have to be taken into account into greenhouse gas emissions. If you look a bit more holistically, because of course there are other environmental impacts that need to be measured. For example, we use our water in a closed loop system, which really reduces the need for clean water and minimizes wastewater production. So also compared to traditional mining and refining, we reduce the need for water up to 97%. It would be, of course, interesting to compare this data to other recyclers, but actually there is a lack of data shared in the public right now, but that's something we would call for, and that will help improve the whole industry. As I said, for the moment, we are controlling and minimizing our Scope 1 and Scope 3 emission, but of course, in the longer term, we'll have to make a greater focus on our Scope 3 emission, which are more difficult to control, of course.
Great. Thank you very much. Very detailed analysis that you have made with this life cycle analysis. But it also brings to my mind that circularity, of course, is one of the sources of, let's say, not only energy, but also reduction of energy, impact that we could use much more. For example, Reinhold, and when we think about all these renewable energies around wind, solar, geothermal, hydroelectric, what would you also propose to think of in terms of technologies and methods? For example, I think of the energy cooperatives, whether also the SMEs locally and circularly can participate to combat climate change.
Yes, we have a global issue that we cannot solve just with large-scale initiatives by the big companies. We need really grassroots developments, innovations. There are a lot of startup innovations as well, but also from the traditional SME environment, and especially also in industrial markets like Europe, Canada, and so what we did a couple of weeks ago, we've had a conference of our companies, and on the one about international hydrogen projects. And what we see is basically we need in our home countries, we need a much faster development. Innovations are there, solutions are being developed in a very fast track, but there is some state regulation needed for larger and higher capacity grids. Smart grids we have, but we need higher capacities. Then for energy storage, also in terms of regulation. And what our companies do is really amazing, and this is encouraging because they're going to other places where they have better better conditions. So they told us SMEs or mid-cap companies, they went to South Africa, to Namibia, to Chile, to Uruguay, to different countries they named, and they're just doing what they are technically already able to do. They have their renewable plants there combined, solar, wind, and even some other resources, and they are doing everything in storing, in bringing it to hydrogen or other formats. But now they need some transportation routes and so on to bring this forward. So this is a combination where there are innovative businesses, but they cannot do it all by themselves. They need much more support also from the governments. But then it works out.
So I see not only circularity is an alternative source of energy or a tool to reduce, but also less bureaucracy. If the companies go to other countries and can do it what they should do in Europe, but they do it there, then there is a reason why, most probably.
You know what you're talking about? Bureaucracy.
Yeah. And Frederic, my last question, and then we also open a little bit the question to the possibility for questions to the public, which are patiently listening to us. Oil and gas extraction will not stop overnight. It will take another 20 years, most probably, and maybe more, as the demand for energy products continues to grow strongly. Considering this oil and gas extraction is primarily for energy purposes, but also makes up a significant proportion of petrochemical products. How can we get around this reality and still meet our environmental objectives?
Yeah, oil and gas, very interesting topic indeed. So I think to answer this question, I will first start by another question. Why did we move from renewable energy to oil and gas? Before we used the oil and gas for the start at the beginning of the Industrial Revolution, we used renewable energy for millennia. Winds for our boats, water for our mills, horses for our agriculture. It worked quite well for that period of time, and then we had an increase of oil and gas consumption. And there are many reasons behind that, but some of them are because petrol, let's say, fossil fuel, is a very easy fuel to use. It can be found very easily, it can be extracted very easily, and the energy is very dense. For a volume of fossil fuel, you have a lot of energy. It's easy to transport, and it's very stable. And now, well, we need to have the same benefits or to find this somewhere with renewable energy. And indeed, you are right. Oil and gas is now a big portion of our CO2 emissions. If you look at the greenhouse gas emissions emitted around the world for a year, roughly 75% of these emissions come from fossil fuels. The rest, it comes from the cement industry, it comes from chemical reactions and from agriculture, if you think at crops, cows, and so on. So to decarbonize our society, to get eventually to carbon neutrality, there are many ways, but certainly two. We can use less energy, and we can use energy that is less carbonated. So I'll just give you an example how to illustrate how hard it is to use less energy. Let's put ourselves back into a horrible period, 2020, COVID-19, lockdown, we're all at home, we don't travel, we don't go to restaurant, we don't shop, we don't do anything at all. Do you know by how much percent we reduce our greenhouse gas emissions during that year? 5%. I'm sure some of you would have 10, 15, 20, even 25%. It's only 5%. So reducing our energy is the quantity of energy we use. It's very, very difficult, even though we are completely locked up at home. So that's certainly a way to go. But the other way is to work on decarbonizing our energy. And there are some studies out there that are trying to figure out how much it will cost. And there is a very recent one from the Energy Transition Commission. And they calculated that to decarbonize the energy that we use, we need to invest around $3.5 trillion per year. 3.5 trillion US dollar per year. Is it a lot or not? Well, it's a matter of perspective. First, this budget needs to go around 70% of it to electricity because we are moving towards an electrified world. I'm sure Lifecycle would agree with that. So we need to find ways to produce more electricity with less fossil fuels. So it requires a lot of investment. So that's one thing. The other thing is we need to compare, that's acting against climate change, but we need to compare that to what would be the cost to not do anything for climate change. The cost of inaction. That's something that is starting to be a very important aspect for companies. And studies show that it's pretty much the same cost. So suffering from climate change would cost around 3.5 trillion US dollar per year for the next 70 years. And that's a study, so it could be 4 trillion, it could be 2 trillion. I think it's not the point. The point is right now, suffering from climate change, so saving money for the next 50, 70 years to brace for impact, or investing today, creating value and mitigating for climate change, today, it's pretty much the same cost, virtually.
But indeed today, because yeah,
I had a look.
If that all would be together, and if we had that money already earned, let's say, the point is what you the money that you have to spend, you first have to earn it. And we know how difficult it is. For example, the European Union produces every year 15 trillion of GDP, but to, let's say, move money from one cash to another is big challenge anyway. Unfortunately, let's say I have just 2 minutes of time for one question from the public. If there's somebody that would like to add a point or suggestion or ask a question to one of the panelists. Okay, then I would say we proceed to the next round. And thank you very much. And I thank my panelists for their very interesting insights. And we are here. We will stay here in the afternoon if you want. You can reach out to them and network further. Thank you very much.